Dear 12th standard students, today we are going to see the important topic potentiometer in the current electricity lesson. I think already you have awareness about or knowledge about in previous topic Wheatstone bridge, meter bridge. In that same follow that potentiometer. So what is potentiometer? Potentiometer is an instrument which is used to accurately measure the potential difference, current and resistance. See the potentiometer instrument. This is the potentiometer instrument. It's a very important thing. Using this instrument, we can accurately measuring the potential difference, current and resistance. Already you know about one more instrument, voltmeter. Voltmeter is an instrument which is used to measuring the potential difference, but that instrument not accurately measuring the actual potential difference, because voltmeter measuring the potential difference between 2 points in a current carrying circuit, it requires a feeble current. So voltmeter will not accurately measuring the potential difference between 2 points in a current carrying circuit. But potentiometer is an instrument which is used to measuring the accurate potential difference between 2 points in a current carrying circuit. See the instrument. Potentiometer. Potentiometer instrument, it consists of 10-meter long uniform manganese wire. The 10-meter uniform long manganese wire is divided into 10 segments or 10 equal parts. See the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10-meter uniform manganese wire is divided into 10 segments. Each segment has length 1 meter. All 10 segments is arranged on a wooden board. All 10 segments are fixed on a wooden board parallel with each other. See each 1 meter length of manganese wire is stretched on a wooden board parallel with each other, and also ends of the manganese wire is fixed with the copper strips with the binding screws. See, first end of the manganese wire and the last end of the manganese wire. So first end and the last end is brought into same side of the potentiometer instrument. And also one more thing, a meter scale. A meter scale is fixed on a wooden board which is parallel to the all 10 segments of uniform manganese wire. So this is the potentiometer instrument construction. So keep it in your mind. Potentiometer instrument, it consists of 10-meter long uniform manganese wire. All 10-meter uniform manganese wire is divided into 10 segments. All 10 segments of manganese wire is stretched parallel with each other on a wooden board. At the ends of the manganese wire is fixed with the copper strips by using binding screws, and the first end and the last end of the manganese wire is brought into same side of the potentiometer instrument. And one more thing, a meter scale. A meter scale is also fixed on a wooden board which is parallel to the potentiometer wire instrument. So this is the potentiometer instrument. Now see the potentiometer principle. Principle of potentiometer. So before going to see the principle of potentiometer, first we draw the circuit diagram of potentiometer. Is a battery, key, CD is the segment of potentiometer wire. Here battery, key and CD is the segment of potentiometer wire. All these connected in series form a circuit that is called primary circuit of potentiometer. Then take one primary cell, positive terminal of the primary cell and the negative terminal of the primary cell. EMF of the cell E. Positive terminal of the primary cell is connected to the C point on the potentiometer wire. Negative terminal of the primary cell is connected with the galvanometer, and another end of the galvanometer is connected to the high resistance. Then next end of the high resistance is connected with the metal jockey J. So therefore, primary cell, positive terminal of the primary cell is connected to the C terminal. The C terminal is nothing but one end of the potentiometer wire. Negative terminal of the cell is connected to the galvanometer. Next end of the galvanometer is connected to the high resistance. Then final end of the high resistance is connected to the metal jockey. So this forms a secondary circuit. So in the potentiometer instrument, battery, key and potentiometer wire CD forms a primary circuit. Then another primary cell, galvanometer, high resistance, metal jockey, this forms a secondary circuit. Now we are going to see principle of potentiometer. Battery sends the steady electric current I through the potentiometer wire. The CD is the potentiometer wire. This battery, keep it in your mind, this battery sends the steady electric current I through the potentiometer wire CD. Small r is the resistance per unit length of the potentiometer wire. So where small r is the resistance per unit length of the potentiometer wire. This CD is the potentiometer wire. This potentiometer wire has a resistance. We don't know that. But small r is the resistance per unit length of the potentiometer wire, or resistance in 1 meter length of the potentiometer wire, meaning of resistance per unit length. Resistance in 1 meter length, that is the meaning of resistance per unit length. Then I is the steady current through the potentiometer wire. Steady current through the potentiometer wire. So now this steady current through the potentiometer wire, according to Ohm's law, V is equal to IR. Potential drop across the any segment we can calculate by using Ohm's law. V is equal to IR. I is the steady current through the segment. R is the resistance of the segment generally. Now, steady electric current establishing through the potentiometer wire. Now, take a metal jockey. That metal jockey may be electrical contact at any point on the potentiometer wire. So this metal jockey may be contact on the any point on the potentiometer wire. At this point, galvanometer shows a zero deflection. So that metal jockey may be electrical contact at any point on the potentiometer wire. I think at this point, galvanometer shows a zero deflection. At that moment, potential drop across this length of the segment of potentiometer wire. This is length of the potentiometer wire. Whenever that metal jockey is maybe electrical contact at this point, galvanometer shows a zero deflection across this length of the segment L. potential drop across this length. How we can calculate potential drop across this length? So potential drop across this length, which is equal to EMF of the cell, because potential drop across this length, which is equal to EMF of the cell, or potential drop across this length, which is balances the EMF of the primary cell. That's why galvanometer shows a zero deflection. So how we can calculate the potential drop across this balancing length? By using Ohm's law. V is equal to potential difference across this balancing length. V. I is the steady electric current through the potentiometer wire I. R is the resistance, but we are going to calculate the resistance of this segment. We need a resistance of this segment only, not resistance of the entire potentiometer wire. We want to calculate the resistance of this segment. So therefore, already we know that small r is the resistance per unit length of the potentiometer wire. But we want to calculate resistance of this segment only. Per unit length resistance r multiply with L, we get resistance of this segment. So potential drop across this balancing length L across the balancing length V, which is equal to EMF of the primary cell, E, which is equal to I, resistance of this segment RL. So this is important thing. Whenever metal jockey may be electrical contact at any point on the potentiometer until galvanometer shows as reflection, at that moment potential drop across this balancing length, which is equal to EMF of the primary cell. So EMF of the primary cell E is equal to IRL, where I is the steady current through the potentiometer wire, R is the resistance per unit length of the potentiometer wire, L is the balancing length of the potentiometer wire. So from this equation, EMF of the primary cell is directly proportional to balancing length. So here, steady current through the potentiometer wire remains constant, resistance per unit length of the potentiometer wire remains constant, but only variable balancing length. So EMF of the primary cell E is directly proportional to balancing length L. If primary cell EMF is increases, we get balancing length is larger value, which means EMF of the primary cell is directly proportional to balancing length. This is a very important thing. It is a principle of potentiometer. If increasing the EMF of the primary cell, we get a balancing length is larger value. Further, decreasing the EMF of the primary cell, we get reducing the balancing length. So we can conclude the EMF of the primary cell is directly proportional to balancing length. It's an important thing. It is the principle of potentiometer. Dear students, we finished what is potentiometer and principle of potentiometer. So keep it in your mind. Potentiometer is an instrument which is used to measuring the accurate determination of potential difference between 2 points in a current carrying circuit. Next one, you clear about principle of potentiometer. EMF of a cell is directly proportional to balancing length. If EMF of the cell is increases, balancing length also increases. EMF of the cell decreases, balancing length also decreases. So next, one of the applications of potentiometer. Using potentiometer, we can compare the EMF of the two primary cells by using potentiometer. That is one of the applications of potentiometer. See, comparison of EMF of two primary cells using potentiometer. See the circuit. battery, key, rheostat, connected across the potentiometer wire. CD is the potentiometer wire. See, battery, key, rheostat and potentiometer wire CD is connected in series. This forms a primary circuit. Positive terminal of the battery is connected to the C end of the potentiometer wire. Last end of the rheostat is connected to the D end of the potentiometer wire. Next, see this entire arrangement: terminal M, terminal N, terminal M1, terminal N1, terminal M2, terminal N2. It is one of the important element. It is called DP-DT switch, double pole to double throw switch. DP-DT switch. Double pole, double throw switch. It has 6 terminals. 1, 2, 3, 4, 5, 6. C end of the potentiometer wire is connected to the M terminal of DP-DT switch. Then N terminal of the DP-DT switch is connected with the galvanometer. Then another end of the galvanometer is connected with the high resistance. Then another end of the high resistance is connected with the metal jockey J. Next, take 2 primary cell. One of the primary cell has a EMF E1. Another cell has a EMF E2. Take first cell has a EMF E1 is connected across the terminal of DP-DT switch M1, N1. This primary cell of EMF E1. Take another one primary cell. It is connected across the 2 terminals of a DP-DT switch M2 and N2. As a EMF E2. So, you note out that positive terminal of the battery in the primary circuit and positive terminal of the first primary cell has EMF E1 and positive terminal of the second primary cell E2 is all in this positive terminal is connected to the same end of the potentiometer wire C. This is positive terminal, this is positive terminal. Second cell, primary cell, positive terminal is connected to the same end or same side of the potentiometer wire at the C point. So next, N terminal of the DP-DT switch is connected to the metal jockey through galvanometer and high resistance. This metal jockey may be electrical contact at any point on the potentiometer wire. So this entire segment or entire arrangement forms the secondary circuit. When the key is pressed, when a steady electric current establishing or flowing through the potentiometer wire I. Already we know that R is the resistance per unit length. I is the steady current. Steady current through the potentiometer wire. Initially, in the DP-DT switch is pressed towards the first primary cell. Now the electrical contact M, M1, N, N1. Now that second primary cell is disconnected from the secondary circuit. Now that metal jockey is moves over on the potentiometer wire at any point. This is the arrangement. There are two primary cells. One primary cell is included in the secondary circuit. At that moment, second primary cell is disconnected from the secondary circuit. Now, when steady electric current flows to the potentiometer wire, take the metal jockey. That metal jockey may be electrical contact at this point. Galvanometer shows a zero deflection. At that moment, balancing length L1. Potential difference across this balancing length due to steady current flows to the potentiometer wire. Potential difference across this balancing length L1, which is equal to EMF of the primary cell E1. According to principle of potentiometer, EMF of a cell across this balancing length, which is equal to IRL. But here, EMF of the primary cell E1, metal jockey may be electrical contact at this point. Potential difference across this balancing length, which is equal to EMF of the cell. So, EMF of the cell E1, which is equal to steady current through the potentiometer wire, resistance per unit length of the potentiometer wire, but now balancing length is L1, equation number 1. Now, in the dp-dt switch is pressed towards second primary cell. Now, first primary cell is disconnected from the secondary circuit and the second primary cell is included in the secondary circuit. Now once again, when metal jockey is may be electrical contact at any this point. At this point, galvanometer shows a zero deflection. So now balancing length across this segment is L2 because this balancing length is corresponding to second primary cell has a EMF E2. So therefore, potential difference across this balancing length L2, which is equal to EMF of the another cell E2. So according to principle of potentiometer, EMF of the second primary cell E2, which is equal to IRL2, equation number 2. But now in our main aim, compare the EMF of the two given primary cell. Equation 1, equation 2. Equation 1 divided by equation 2. E1 divided by E2, which is equal to IRL1 divided by IRL2. So IR get cancelled with each other. Then E1 divided by E2, which is equal to L1 divided by L2. This is important expression. We can compare the EMF of the two given primary cell E1 and E2 by using principle of potentiometer. E1 divided by E2 is equal to L1 divided by L2. So from this equation, one primary cell has a EMF E1. We know that second primary cell EMF, by using that equation, calculate the unknown EMF of the primary cell. So known EMF E1, unknown EMF E2. So therefore, E2 divided by E1, which is equal to L2 divided by L1. So E2, which is equal to L2 divided by L1 into E1. E1 is known EMF, E2 is unknown EMF. rearranging this expression, we can calculate the unknown EMF of the primary cell by using this potentiometer. So one of the applications of potentiometer instrument, compare the EMF of the two given primary cells. So dear students, in this video you watch clearly, you get awareness about, you get knowledge about what is potentiometer, what is principle of potentiometer, what is the use of potentiometer, or one of the applications of potentiometer. Potentiometer is an instrument which is used to measuring the accurate potential difference. Principle of potentiometer is EMF of the cell is directly proportional to balancing length, and one of the applications of potentiometer, comparison of EMF of two given primary cells using potentiometer. And you watch clearly each and every seconds in this video, you get knowledge about this topic. Thank you.